Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an isometric 3D projection of an engineering object into which the front view face, the top view face and the left hand side view face of the solid, they have been appropriately combined into a single 3D isometric projection over here. So using the information available with us through this single 3D isometric projection, we are required to obtain the front view orthographic projections, the top view orthographic projections and the left hand side view orthographic projections over here. And in order to evaluate the orthographic projections of the solid, we need to determine the dimensions of the front view face, top view face and the left hand side view face of the solid. Now when the observer is going to look at the solid from the front view orientation, so we observe that the width of the solid happens to be equal to 74 millimeter, while the height of the solid, it is equal to 33 millimeter. Therefore, the dimensions of the front view face will be measuring 74 millimeter by 33 millimeter. Similarly, when we are going to look at this object from the top view orientation, so once again, the width of the solid, it is equal to 74 millimeter, while the depth of the solid has been provided to us as 47 millimeter. So here we can check this depth of the leg which is lying onto the front side. So this depth has been provided to us as 5 millimeter. Then this depth, it is equal to 37 millimeter, and then this depth is equal to 5 millimeter. So the total depth of the solid, it happens to be 47 millimeter. Therefore, the dimensions of the top view face will be measuring 74 millimeter width of the solid and 47 millimeter depth of the solid. Now when we are going to look at the solid from the left hand side view orientation, so we are going to observe depth of solid, it is equal to 47 millimeter, while the height of solid, it is equal to 33 millimeter. So the left hand side view face of the solid will be measuring 47 millimeter by 33 millimeter. Now let us proceed to evaluate the orthographic projections of this engineering object. So now in order to obtain the orthographic projections of this solid, we have drawn XY reference line, X1, Y1 reference line, and we have also obtained the transfer line originating from the intersection of XY reference line and the X1 Y1 reference line, and this transfer line, it is inclined at an angle of 45 degree with respect to the XY reference line, and we are going to use this transfer line to transfer the distances alongside the depth of the solid from the top view orientation into the left hand side view orientation over here. Now since we are required to obtain the orthographic projections of the solid into the first angle projection method, so the front view orthographic projections, they will be obtained above the XY reference line. Similarly, the top view orthographic projections will be obtained below the XY reference line, and the left hand side view orthographic projections of the solid will be obtained on right hand side of the front view above the XY reference line. Now we know that the dimensions of the front view face of the solid, they are measuring 74 millimeter width of the solid and 33 millimeter height of the solid. So here into the front view projections, now we have drawn two vertical projector lines which are separated by a distance of 74 millimeter, which happens to be equal to width of the solid over here. So this is width of the solid equal to 74 millimeter, and these two vertical projector lines, we have appropriately extended them into the top view orthographic projection area over here, because into the top view projections also we are going to require width of the solid equal to 74 millimeter. Now we also know that the height of the front face, it is equal to 33 millimeter. Now at a height of 33 millimeter from the XY reference line, we have obtained a horizontal projector line into the front view orthographic projections, and we have extended this horizontal projector line into the left hand side view projections over here, because into the left hand side view projections also we are going to require height of the solid equal to 33 millimeter over here. Now into the top view face, we know that the dimensions are 74 millimeter width of the solid and 47 millimeter depth of the solid over here. So 74 millimeter width of the solid we have already obtained. Now we are going to draw two horizontal projector lines into the top view orthographic projections separated by a distance of 47 millimeter, which happens to be equal to width of the solid over here. And these two horizontal projector lines, they have been appropriately transferred using this transfer line into the left hand side view orthographic projections over here, such that the depth of the solid 47 millimeter from the top view projections will be appropriately transferred into the left hand side view projections over here. So now we can check the left hand side view face of the solid. It has been obtained into the orthographic projections over here, measuring 47 millimeter depth of the solid and 33 millimeter height of the solid over here. Now let us proceed to evaluate orthographic front view projections of the solid. Now when the observer is going to look at the solid from the front view orientation, let us evaluate different elements of the solid alongside the width of the solid over here. Now as we look at the solid from the front side, so we observe that we can divide the solid into two parts over here. Element number one, it is a horizontal wave which is having a rectangular slot at the base of the solid, and it is also carrying an extended semicircular slot at the middle of this particular horizontal web over here. Then here we have got a cubical block resting on top of this horizontal web, which is our element number 2. Now corresponding to this cubical block, which is carrying an angular slot at the top and a circular hole at the center over here. Now we can check this width corresponding to element number 2 happens to be equal to 28 millimeter from the right hand side face of the solid. So now we can check into the front view projections from the right hand side face of the solid. We have measured a distance of 28 millimeter and we have obtained a vertical projector line into the front view projections, and we have appropriately extended this vertical projector line into the top view projections over here. So with this face of the element number 2 has been defined over here. Now we can check this circular hole. It is located alongside the center of this depth of the solid, that is 47 millimeter. Whereas this cubical block is concerned, so we can check this width of the cubical block, it is equal to 28 millimeter, while the center of the circular hole, it is not located centrally alongside this width of 28 millimeter. So we have to measure a distance of 15 millimeter from this face in order to obtain the center point of this circular hole over here. So automatically this distance will be 13 millimeter from the right hand side face or 15 millimeter from this face of the element number 2. So from this face of the element number 2, we are going to measure a distance of 15 millimeter towards the right hand side face of the solid. So from this face, as we move 15 millimeter towards the right hand side face, so the center point of this circular hole will be located over here. So now we have marked a distance of 15 millimeter from this surface over here, which is corresponding to element number 2, and we have marked a vertical projector center line into the front view projections, and we have extended the center projector line into the top view projections as well. And now we know that the diameter of the circular hole, it is equal to 7 millimeter. So we have to take an offset of 3.5 millimeter on the left hand side and 3.5 millimeter offset on the right hand side of this center projector line, so that these two end point, this end point and this end point corresponding to this diameter of the circular hole can be located over here into the front view projections over here. So two vertical black projector lines depicting the end points of the diameter of the circular hole, they have been obtained over here, and these two vertical black projector lines, they have been appropriately extended into the top view projections as well. Now next we have got a semicircular elongated hole over here into the horizontal wave, which is our element number 1. So here we can check, corresponding to this hole, here we have got the elongated portion. On the either side we have got the semicircular slots over here. So the center point corresponding to the first semicircular slot, it is lying at a distance of 16 millimeter from the left hand side face of the solid. This is left hand side face of the solid. Then the elongated portion of the slot, it is measuring 13 millimeter width over here. So these two distances, 16 millimeter corresponding to the center point of the first semicircular slot onto the left hand side, and this is 13 millimeter. This is again the center point corresponding to the second semicircular slot over here. So this way, two vertical center projector lines we have been able to obtain into the front view projections, and we have extended these two vertical center projector lines appropriately into the top view projections over here. And then we understand that this distance is equal to 13 millimeter, that is alongside the depth. This particular slot, it is having depth equal to 13 millimeter. So with this as center, we will be able to obtain this depth of the slot as 13 millimeter when the radius is equal to 6.5 millimeter. This radius is also 6.5 millimeter over here. So now from this center line and from this center line, these two center lines we have already obtained. So now we need to obtain the extreme points corresponding to this elongated semicircular slot over here. So this extreme point needs to be located and this extreme point needs to be located. So now from this point, which is at a distance of 16 millimeter from the left hand side face, we need to move 6.5 millimeter towards the left hand side face. Similarly, from this point, we need to move 6.5 millimeter towards the right hand side face over here. So now we have taken an offset of 6.5 millimeter onto the left hand side of this left side center projector line. Similarly, we have taken an offset of 6.5 millimeter towards the right hand side face of the solid from the second vertical center projector line over here, so that these two black vertical projector lines which we have obtained over here, they are going to depict these two extreme ends corresponding to this elongated semicircular slot which is lying into the horizontal web, that is element number 1 over here. And these two black vertical projector lines, they have been appropriately extended into the top view projections over here as well. So when we look at the solid from the front side, let us evaluate different elements of construction of the solid alongside the height of the solid. Now we can see, as we are going to look at the solid from the front side. So this horizontal web, it is having height is equal to 14 millimeter. So we have measured a distance of 14 millimeter from the XY reference line, and we have obtained a horizontal projector line into the front view projections, and we have appropriately extended this horizontal projector line into the left hand side view projections as well. Similarly, we know that there is a rectangular slot at the base of the solid which is having height is equal to 5 millimeter. So now we are going to measure height of 5 millimeter from the XY reference line or from the ground. Again, we are going to obtain a horizontal projector line into the front view projections, and we have extended this horizontal projector line into the left hand side view projections as well. Next, we have got this surface corresponding to this angular slot which is lying into the element number 2, which is a cubical block over here. So at a height of 9 millimeter, so this top surface of this slot will be lying over here. So now again another 9 millimeter distance from the top of this horizontal web, which is existing at a height of 14 millimeter from the ground. So we have to mark it out over here. So now at a distance of 23 millimeter from the ground or 9 millimeter above the top surface of this horizontal web, again we are going to obtain a horizontal projector line into the front view projections, and we have to extend this horizontal projector line into the left hand side view projections over here. So with this, the grid work corresponding to all the elements of the solid alongside the width and alongside the height, it has been obtained. So let us darken whatever surfaces which will be visible to the observer from the front view orientation over here. So as the observer is going to look at the solid from the front view orientation, so this L-shaped projection corresponding to the front surface of the solid, it will be visible to the observer in the front view projections over here. And since this L-shaped surface, it happens to be parallel to the vertical plane, so we are going to obtain the true shape projections corresponding to this L-shaped surface onto the vertical plane in the front view projections over here. Next, we can see over here corresponding to this surface which is lying at a distance of 23 millimeter from the ground. So here this surface has been covered by this vertical web over here. So we are going to obtain dotted line or a hidden line projection corresponding to this surface in the front view projections over here, because this surface happens to be perpendicular to the front surface. So this surface will be projected as an edge view projection into the front view projections over here. Next, we have got this rectangular slot into the element number 1, which is the horizontal web lying at the base of the solid. So again, this surface, this complete surface which is lying at a height of 5 millimeter, again it is not visible to the observer from the front view orientation. So we are going to observe the edge view projections corresponding to this big surface over here in the front view projections as a dotted line or a hidden line projection over here. So here we can see at a height of 5 millimeter, we have obtained dotted line projections corresponding to this surface which is not visible to the observer. Next, we have got this hole over here. So we can see we have already identified these two extreme ends of the diameter into the front view projection. And now this hole is starting from this point. It will end at this point over here, 5 millimeter above the base of the solid. So the dotted line or a hidden line projections will be visible as an apparent shape representation into the front view projections over here. That is, this circular hole will be projected as a rectangular projection into the front view projection, and this projection will be the apparent shape projection over here. And finally, corresponding to this elongated semicircular slot over here, again corresponding to these two end points of the semicircular slot over here, we are going to obtain dotted line or a hidden line projections into the front view projection. And again, this part of the slot, it is a true shape, whereas this part of the semicircular slot and this part of the semicircular slot, it is the apparent shape, because here the curvature is involved, here a flat surface is involved. So this surface will be visible over here in the form of a rectangle as a true shape, whereas the two semicircular ends, they will be appearing as apparent shape rectangles into the front view projections over here. Now let us proceed to evaluate the top view projections corresponding to the solid. Now we can see, as per the constructional details of the element number 2, here we have got inclined surface over here at the rear end and inclined surface towards the front end of this angular slot. So this slot has been provided in such a way that this distance and this distance happens to be 10 millimeter, and this distance and this distance happens to be 14 millimeter. So now we are going to measure a distance of 10 millimeter from the rear face and 10 millimeter from the front face of the solid. So we have measured a distance of 10 millimeter from the rear face of the solid, and we have obtained a horizontal projector line into the top view projections, and we have appropriately transferred this horizontal projector line into the left hand side view projections over here. Similarly, corresponding to this distance of this angular slot into the element number 2, again we are going to measure a distance of 10 millimeter from the front surface of the solid, and we are going to obtain a horizontal projector line into the top view projections, and we have transferred this horizontal projector line appropriately into the left hand side view projections over here. In order to locate these 2 points, this point and this point over here, now we need to measure distance of 14 millimeter from the rear face of the solid and 14 millimeter from the front face of the solid. So now we have marked a distance of 14 millimeter from the rear face of the solid, and again we have obtained a horizontal projector line into the top view projections, and we have appropriately transferred this horizontal projector line into the left hand side view projections over here. Similarly, from the front face of the solid, again we have measured a distance of 14 millimeter in order to locate this point, and a horizontal projector line, it has been obtained into the top view projections, and this horizontal projector line has been appropriately transferred into the left hand side view projections over here. Now next we have got this center line, so we can check the depth of the solid, it is equal to 47 millimeter, and this elongated semicircular hole and this circular hole, both are located centrally alongside the depth of the solid. So total depth of the solid, it is 47 millimeter at a distance of 23.5 millimeter from the rear surface. We have drawn a horizontal center projection line, and we have transferred this horizontal center projection line into the left hand side view projections over here. And now we know that this distance, that is the depth of the semicircular elongated slot, it is equal to 13 millimeter. So now we have to take from the center line an offset of 6.5 millimeter towards the rear surface, 6.5 millimeter offset towards the front surface of the solid. So here 2 horizontal black projector lines we have been able to obtain to identify these 2 ends of the semicircular elongated slot over here. So now these 2 black horizontal projector lines separated by a distance of 13 millimeter and at an offset of 6.5 millimeter from the center line towards the rear side and towards the front side of the solid, they have been obtained. And these 2 horizontal black projector lines, they have been appropriately transferred into the left hand side view projections over here. So we have terminated these 2 black projector lines at this height of 14 millimeter because they are existing in element number 1, and the height of element number 1 happens to be equal to 14 millimeter. Another thing we know that corresponding to this circular slot, now these two endpoints of the diameter need to be located. So the diameter is 7 millimeter. So from this center line, we will be taking an offset of 3.5 millimeter towards the rear surface. 3.5 millimeter offset we are going to take towards the front surface of the solid. And we can check these two interior black projector lines we have been able to obtain, which are separated by a distance of 7 millimeter, and they are at an offset of 3.5 millimeter toward the rear surface and 3.5 millimeter toward the front surface of the solid from the center line which we have already obtained. And these two black projector lines, they have been appropriately transferred into the left hand side view projections up to this height, 23 millimeter from the ground, that is at the top surface of this angular slot. And next we have got this particular vertical portion corresponding to element number 1, and this depth on the front side is 5 millimeter. This depth, it is also 5 millimeter toward the rear surface of the solid. So now we are going to measure 5 millimeter distance from the front surface of the solid corresponding to this vertical edge of the leg of this particular element number 1. And we have obtained a horizontal projector line into the top view projections, and we have appropriately transferred this horizontal projector line into the left hand side view projections as well. Similarly, corresponding to this vertical element, again the depth is equal to 5 millimeter from the rear surface of the solid. So from the rear surface of the solid, which is lying over here, again we have measured a distance of 5 millimeter from the rear surface, and we have obtained a horizontal projector line into the top view projections, and we have transferred this horizontal projector line appropriately into the left hand side view projections over here. So with this, the grid work corresponding to various elements alongside the width of the solid, alongside the depth of the solid has been appropriately obtained in the top view orthographic projections over here. So let us evaluate which segments of the solid will be visible to the observer as the observer is going to look at the solid from the top view orientation. So now as we can see, as the observer is going to look at the solid from the top, so this boundary of the object will be visible to the observer. So this boundary we have already plotted over here, right? So this is the boundary which is visible to the observer from the top. Next we have got this element number 2. So this vertical wall or vertical face corresponding to element number 2, it will be visible as an edge view from the top view projections over here. Then we have got this inclined surface and this inclined surface. We can check. This is 10 millimeter. This is 10 millimeter. This is 14 millimeter. This is 14 millimeter. So these two edges now we can join. This is 10 millimeter. This is 14 millimeter. This is 10 millimeter. This is 14 millimeter. One inclined surface is available toward the rear side of the solid. One inclined surface is available toward the front side of the solid. So this angular slot, it has been obtained into the top view projections over here. Now we must consider that this surface, it is parallel to the horizontal plane. So it has been projected as true shape projection into the top view projections over here. Similarly, this surface, it is also parallel to HP. So this has been provided as true shape projection into the top view projections over here. And this surface, this horizontal surface corresponding to the base of this angular slot, this is also parallel to the horizontal plane. So this is also projected as a true shape representation into the top view projections over here. Then we can see this vertical surface and this vertical surface corresponding to this rectangular slot. So both of these vertical surfaces, they are not visible to the observer from the top. So they will be appearing as dotted line or the hidden line projections at a distance of 5 mm from the rear face and 5 mm from the front face. So these two dotted line or the hidden line projections, they have been obtained into the top view projections over here. Next we have got the circular slot. So corresponding to the center point, we can draw a circle having diameter is equal to 7 mm or radius is equal to 3.5 mm. So this circular slot is also represented as true shape projection in the top view projection over here. And corresponding to the semicircular elongated slot, once again it is parallel to the horizontal plane. So we are going to obtain true shape projection of this semicircular slot into the top view projection. So we can check this portion is a rectangular portion, while there are two semicircular arcs which we need to draw from this center point and from this center point, having radius is equal to 6.5 mm. So that this depth should be equal to 13 mm over here. Now when the observer is going to look at the solid from the left hand side view orientation, so this face which is lying towards the left hand side portion of the solid, so this inverted U-shaped surface, it will be visible to the observer from the left hand side face. And since this face is also parallel to the profile plane, so the observer is going to visualize the true shape projection of this inverted U-shaped portion into the left hand side view projections over here. And then we also know that this is the depth 13 mm, and these are two extreme points of this elongated semicircular slot. So corresponding to these two extreme points, we are going to observe hidden line rectangular apparent shape projections corresponding to this elongated semicircular slot into the left hand side view projections over here. So this is the apparent shape. Why this is apparent shape? Because over here it is a semicircular arc, over here it is also a semicircular arc, and we have got a rectangular projection corresponding to the semicircular elongated slot into the left hand side view projections over here. Now corresponding to element number 2, so this portion, it is parallel to the profile plane, so this portion will be visible to the observer as a true shape projection over here. So we can check this projection, this is 10 mm, this is 10 mm, this is 10 mm, this is also 10 mm. So now this projection happens to be true shape projection corresponding to this surface which is parallel to the profile plane. But this long elongated tapered surface and this long elongated tapered surface, because of the less inclination, it will be appearing as an apparent shape highly foreshortened surface onto the left hand side and onto the right hand side portion of the solid over here. So toward the left hand side portion, this portion is being projected as an apparent shape projection over here. On the right hand side, again this long tapered projection, it is projected as very short apparent shape projection into the left hand side view projections over here. And finally here we have got a circular slot which is again not visible to the observer from here. So this is having these two extreme diameter points over here. So corresponding to these two extreme diameter points up to this depth, we are going to have dotted line or the hidden line projections corresponding to the circular slot available with us into the left hand side view projections as an apparent shape projections over here. So this way, this is also apparent shape projection corresponding to the circular slot. So since it is a hidden hole over here, not visible to the observer from the left hand side view orientation, so it will be appearing as a dotted line projections over here. So this way we have been able to obtain front view orthographic projections of the solid, the top view orthographic projections of the solid, and the left hand side view orthographic projections of the solid when the 3D isometric projection of the solid depicting the constructional details of the solid it was provided to us. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.